All right, let's talk about something huge that's happening right now in data extraction. The way we've been scraping the web for years, well, it's dying. An entire era is coming to a close, and what's replacing it is going to change web scraping forever. Let's get into it. Oh, you know this feeling, don't you? That pit in your stomach when this error pops up? You've got a scraper running in production, everything's humming along, and then, bam! Red text starts scrolling, all because a single class name was changed on the front end. And just like that, your entire data pipeline has completely imploded.
Or maybe this one's your favorite. The page loads, the element is right there, you can see it, but by the time your script goes to grab it, whoops, it's gone. The dynamic JavaScript on the page had other plans. It's just so frustrating.
And of course, the dreaded timeout. Your scraper just sits there and waits for an element that is never, ever going to appear. Look, these aren't just little bugs to fix. They're symptoms. They're all pointing to a much deeper problem. We've been using the wrong tools for the job all along.
This isn't just a maintenance headache. This is what I'm calling the selector apocalypse. We are literally witnessing the collapse of an entire methodology that was built on an incredibly fragile foundation.
So let's just get on the same page really quickly. When we say traditional web scraping, what are we talking about? Well, think of tools like Selenium or BeautifulSoup. It has always been about one thing: location. We write a script that gives a very precise, very rigid set of instructions like go to this page, find the div with this exact class, and pull out the text.
And this right here, this is the battlefield. This is why that rigidity is a fatal flaw. I mean, selectors are just so brittle. A simple change from .pricev1 to .pricev2 and your whole operation is dead in the water. Modern front-end frameworks spit out dynamic, meaningless class names that can change with every single build. And you've got content that only loads after your scraper thinks the page is ready. And we haven't even started talking about the incredibly sophisticated anti-bot systems out there.
So here it is, the most crucial point of all. We are trying to scrape living, breathing applications as if they were simple, static documents. The web completely evolved into something new, but our primary scraping tools, they got stuck in the past.
And this slide just illustrates that mismatch perfectly. On one side, you have the old document-era tools, built for a static web with a stable HTML structure. On the other side, you have today's application-era web, a dynamic, living thing where the DOM is constantly in flux. Using a CSS selector here is like trying to find one specific brick in a wall that is actively rebuilding itself right in front of your eyes.
This quote just hits the nail on the head, doesn't it? It perfectly captures that endless, frustrating cycle. You're not actually building a data pipeline, you're just renting one. And the lease is up every single time a developer pushes a front-end update. It is fundamentally completely unsustainable. But what if we could build scrapers that just don't break? This is where we pivot. Let's talk about the solution. A completely new architecture that I call the semantic pipeline, and it's designed for a much more resilient future. Now, this is the question that changes everything. Seriously, think about it for a second. For years, we've been obsessed with location, the XPath, the CSS selector. We've been giving the machine a brittle, fragile map. What if, instead, we just describe the treasure we were looking for and let the machine figure out how to find it? And that leads us to semantic scraping. Instead of using selectors, we use a large language model, like GPT-4 or Claude, to actually understand the page's content. We just tell it, I want the product price, and it uses its contextual understanding to find the element that semantically means price, regardless of its class name or where it is in the DOM.
So here's what this new pipeline looks like. First, we ingest the raw HTML, same as always. But then comes the magic. We convert that complex, messy HTML into simple Markdown, a format the LLM can easily understand. The model then extracts the data based on our intent. And finally, and this part is absolutely crucial, we validate that output against a strict schema to make sure we only get clean, reliable JSON.
So why does this work so well? Well, LLMs are trained on linear text, not these complicated tree-like structures you see in HTML. Trying to feed raw HTML to a language model is super inefficient and often just fails. But Markdown? It's just text. It preserves all the important meaning, the headings, the lists, the links, but in a simple format the LLM can process with incredible accuracy. This conversion step is the secret sauce.
Now, getting the data is only half the battle. We also have to validate it. This is where a tool like Pydantic, a fantastic data validation library, comes into play. It lets us define a strict schema, a set of rules, before we even start. We can enforce that a price has to be a number or a date has to be in the correct format. This completely prevents that classic garbage in, garbage out problem. It's our quality guarantee that if the pipeline gives us data, it's data we can actually trust.
So, okay, the semantic pipeline is resilient. That's great. But is it practical? Let's talk about the real value here and completely reframe this conversation around cost. This table really says it all. The very things that kill a traditional scraper, a renamed class, a different DOM structure, a moved element, they are completely irrelevant to a semantic scraper. As long as a human being can look at the page and figure out what the price is, the LLM can too. The meaning survives even when the structure changes completely.
Okay, let's just tackle the elephant in the room. This is the #1 question I get. But isn't running these large language models really expensive? And you know what? It's a fair question. API calls cost money. But is it expensive? Well, that really depends on what you're comparing it to. See, the cost of LLM tokens is a small, predictable operational expense. It scales linearly with your usage. But the cost of human maintenance, the emergency engineering hours you spend at 2 a.m. fixing a broken scraper because some e-commerce site changed a button color, that cost is massive, it's unpredictable, and it grows exponentially with every new scraper you deploy.
So the crucial point is this. We've been measuring the wrong thing this whole time. The real cost of scraping isn't the infrastructure. It's the constant reactive firefighting. The token cost is visible and linear. The maintenance cost is hidden and exponential. Look, this isn't some theoretical future we're talking about. This is happening right now. We are officially here. Welcome to the semantic era of data extraction. The fundamental skill for web scraping is no longer about writing the perfect XPath selector. It's about being able to clearly define your data needs and validate the results you get back. We've moved away from precision engineering and into the world of semantic intent.
So let's just recap the key takeaways. First, selector-based scraping is fundamentally brittle. It's a dead end. Second, the modern web requires tools that actually understand applications, not just static documents. Third, semantic pipelines offer true resilience. Fourth, data validation with tools like Pydantic is absolutely non-negotiable. And finally, the most important takeaway, the real cost isn't in the API tokens, it's in the emergency engineering hours you spend putting out fires.
And that's a wrap on the death of CSS selectors. If this explainer gave you a new perspective on data extraction, do me a favor and hit that like button. Share it with a colleague who you know is tired of fixing broken scrapers. And of course, make sure to subscribe to Lollit Official for more deep dives into the future of tech. Thanks for watching.